Good day, my dear students. How are you? This is your further algebra lecturer, Mr. Richard Ayaman. We are to continue with binomial expansion. A binomial expansion is a polynomial with only two terms. A binomial expansion is a polynomial with only two terms. Example: x plus 1 x raised to the power 2 plus 2, x raised to the power 3 plus x, a plus 4, etc. And it may interest you to note that if binomial is a polynomial with only two terms, then what is a binomial expansion then? Binomial expansion let's first deal with an example. Let's say I have a plus y raised to the power 2 as shown. In this, when it is expanded and simplified, you get a raised to the power 2 plus 2ay plus y squared. There could be higher powers of this nature. In other words, there could be a plus y all raised to the power 3, a plus y all raised to the power 4, and so on. And in each case, we need to expand and simplify. By so doing, we come to the term binomial expansion. Binomial expansion. So, with this, we can say that binomial expansion is the expansion and simplification of the powers of a binomial. Now let's move on to binomial theorem. Now let's move on to binomial theorem. For every system, there is a law governing the way we approach its processes. The same thing applies to binomial expansion. To be able to work out a binomial expansion effectively, we need to apply a theorem called binomial theorem. And it states that 1 plus x raised to the power n equal to 1 plus nx plus n into bracket n minus 1 bracket close times x raised to the power 2 all over 2 factorial plus n times n minus 1 times n minus 2 times x raised to the power 3, all divided by 3 factorial. Then it will go on till we get to the last term, which is plus x raised to the power n, as shown. So no matter the power of the binomial that you have, you can always use the binomial theorem to expand it. And we should note that in this case, n is always a rational number, and the x, which is the variable concerned, its value shouldn't be greater than 1 or equal to 1, and neither should it be less than -1 as mathematically expressed here. Also, let's say the constant term 1 is not 1 but is a different number as shown here, a. How do we express this then in binomial theorem? Just like what you did under method of completing the square, don't forget you always try to make the coefficient of the x 1. So in this case, in order to get the constant 1, we need to factorize out a. Then we will end up getting a times into bracket 1 plus x divided by a, bracket close, all raised to the power n. Simplifying further, we will get a raised to the power n all times 1 plus x over a all raised to the power n. So if you look at the last term, it's a matter of factorizing out a raised to the power n. It's a matter of factorizing out a raised to the power n and then multiplying by the rare binomial theorem, that's where the coefficient or the constant is 1 from the earlier stage. And in this case, the a concerned here shouldn't be equal to 1 or 0. And the x maintains the previous condition, that's x -1 is less than or equal to x and x less than 1. Now, the binomial theorem is normally used to expand and simplify binomials of higher powers, as I stated earlier. Besides that, it can also be used to evaluate such functions as 0.99 raised to the power 4, 1.01 raised to the power 5, and so on. So with this, let's solve some examples. One, write down the binomial expansion of 1 plus x all raised to the power 5. Simplify all the terms and hence evaluate 1.01 raised to the power 5 to 3 decimal places. Now the solution goes this way. First, the binomial theorem states that 1 plus x raised to the power n is equal to 1 plus nx plus n times n minus 1 times x squared all over 2 factorial plus n times n minus 1 times n minus 2 times x raised to the power 3 all over 3 factorial. Then plus up to the last term, which is x raised to the power n, as shown. In this case, if we are to compare what we are to solve, that's 1 plus x all raised to the power 5 in expanding form. N here is equal to 5. So wherever there is n in the binomial theorem, we put 5 there. And by so doing, we end up getting 1 plus x all raised to the power 5 being equal to 1 plus 5x plus 5 times 5 minus 1 all times x squared all divided by 2 factorial. Then all plus 5 times 5 minus 1 times 5 minus 2 times x cubed all divided by 3 factorial. Then all plus 5 times 5 minus 1 times 5 minus 2 times 5 minus 3 all times x raised to the power 4 and all divided by 4 factorial. Then plus x raised to the power 5. In simplification form, we will end up getting 1 plus 5x plus 2x squared divided by 2 plus 60x cubed divided by 3 plus 120x raised to the power 4 divided by 4 plus x raised to the power 5. And the final simplification will be 1 plus 5x plus 10x squared plus 10x cubed plus 5x raised to the power 4 plus x raised to the power 5. Now from the question, you might said hence. Hence here means whatever we got in our previous solution, we are to apply it in solving the subsequent solution. So the question stated that hence evaluate 1.01 raised to the power 5. The first thing we need to do here is we try to express 1.01 raised to the power 5 in the form 1 plus x raised to the power 5. And with this, we get 1 plus 0.01 all raised to the power 5. Now comparing 1 plus 0.05, 1 plus 0.01 all raised to the power 5 to 1 plus x all raised to the power 5, we will end up getting x being equal to 0.01. And this in standard form, we will get 10 raised to the power -2. So the solution goes this way. What it means here is that from our previous solution, where we got 1 plus 5x plus 10x squared plus 10x cubed plus 5x raised to the power 4 plus x raised to the power 5, we will substitute the value of x into that expression. And with this, we will end up getting 1 plus 0.1 all raised to the power 5 being equal to 1 plus 5 times 10 raised to the power -2. Don't forget the previous was 5x, and in this time x is equal to 10 raised to the power -2. That's why here you can see that the x is replaced by 10 raised to the power -2. Hence 5 times 10 raised to the power -2. All plus, that's following the same process. We will end up to be plus 10 times 10 raised to the power -2 all raised to the power 2 plus 10 times 10 raised to the power -2 all raised to the power 3 plus 5 times 10 raised to the power -2 all raised to the power 4, and then plus 10 raised to the power -2 all raised to the power 5. In simplified form, we will end up getting 1 plus, don't forget, from the laws of indices, that's from the exponent law. Whenever you are multiplying an index form raised to another exponent, you multiply the power of the base times the exponent outside. So with this, we ended up getting 1 plus 5 times 10 raised to the power -2 plus 10 times 10 raised to the power -4 plus 10 times 10 raised to the power -6 plus 5 times 10 raised to the power -8 plus 10 times 10 raised to the power, plus 10 raised to the power -10. Then in value, we will end up getting 1 plus 0.05 in evaluation, all plus 0 plus 0.00001, which we will end up getting 1.0510, which ends up 1.051 to 3 decimal places as the question demanded. Now let's move on to the second example. That's example 2. Expand and simplify up to the 7th term of 1 plus 2x all raised to the power 10. Hence, evaluate 1.2 raised to the power 10 to the 7th term. Now, the solution goes this way. First, we state our binomial theorem. Then second, comparing 1 plus 2x all raised to the power 10 to 1 plus x all raised to the power n. It means our x here is equal to 2x and our n is equal to 10. So we substitute 2x in place of the binomial theorem, then 10 in place of the n, that's the exponent. And we end up getting 1 plus 10 times 2x plus 10 times 10 minus 1 times 2x raised to the power 2 all over 2 factorial. Then all plus 10 times 10 minus 1 times 10 minus 2 times 2x raised to the power 3 all over 3 factorial plus, that's all plus 10 times 10 minus 1 times 10 minus 2 times 10 minus 3 times 2x raised to the power 4 all over 4 factorial. And all plus 10 times 10 minus 1 times 10 minus 2 times 10 minus 3 times 10 minus 4 times 2x raised to the power 5 all over 5 factorial. Then all plus 10 times 10 minus 1 times 10 minus 2 times 10 minus 3 times 10 minus 4 times 10 minus 5 times 2x raised to the power 6 plus, all divided by 6 factorial. Then we would have gone further, but the question limited us to the 7th term. And the 7 terms ends here. That's why we brought the plus, then dot 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 means, and so on. Then in simplified form, we will end up getting 1 plus 20x plus 180x squared plus 960x cubed plus 3360x raised to the power 4 plus 8064x raised to the power 5 plus 13,440x raised to the power 6 plus and so on. Don't forget, the term ends on the 7th term. So we finished with the first part of the question. And don't forget, the hence. So it means we are going to use our expression, our previous simplified term, to solve the subsequent question. And with this, we try to express 1.2 raised to the power 10 in the form 1 plus x raised to the power 10. And by this, we will get 1.2 raised to the power 10 being equal to 1 plus 0.2 all raised to the power 10. Now comparing 1 plus 0.2 all raised to the power 10 to 1 plus 2x all raised to the power 10. Comparing 1 plus 0.2 all raised to the power 10 to 1 plus 2x all raised to the power 10, it means 2x will be equal to 0.2. Now making x the subject, we will end up getting x being equal to 0.1, which in standard form is 10 raised to the power negative 1. Hence, we can conveniently say that 1.2 raised to the power 10 is equal to, that's in place of x, in the previous expression, that's the simplified expression, we put 10 raised to the power negative 1 there. So, we will get 1 plus 20 times 10 raised to the power 1 plus 180 times 10 raised to the power negative 1 all raised to the power 2 plus 960 times 10 raised to the power negative 1 all raised to the power 3 plus 3,360 times 10 raised to the power negative 1 all raised to the power 4 plus 8,064 times 10 raised to the power negative 1 all raised to the power 5 plus 13,440 times 10 raised to the power negative 1 all to the power 6 and so on. Thus we end at the 7th term. And applying the exponential law of indices, we end up getting this 2nd term, and which in all the value will be 6.19008. Now I would like you to go and master the example 3, though it has been solved there. But I want you to go and master it yourself. And probably the other examples, example 4. Then you try the following questions. One, using binomial theorem, expand and simplify 1 plus half a all raised to the power 6. Given that 3.15 all raised to the power 6 is equal to 3 raised to the power 6 times b, use your resource to estimate the value of b, correct to 4 decimal places. Trial question 2. Use binomial theorem to expand and simplify 2 plus x all raised to the power 6 and 2 minus x all raised to the power 6 hence find 2 plus x all raised to the power 6 minus 2 minus x all raised to the power 6. Evaluate 2.01 raised to the power 6 minus 1.99 raised to the power 6 by using the result in I. Now, let me give you the clue in the second trial question. You need to factorize out 2. And you end up applying the second part of the binomial theorem. That's a plus x all raised to the power n. The same thing will be applied to the 2 minus x all raised to the power 6. I hope you are okay. Now let's move on to Pascal's triangle. Pascal's triangle. This is another way or another method of simplifying and expanding binomial of exponents or of higher exponents. I take it again. Another method by which we can expand and simplify higher powers of binomial is by using the Pascal's triangle. One may ask, what is Pascal's triangle then? Pascal's triangle is the arrangement of numbers in a triangular form such that a row represents the power, that's the exponent of the binomial, whilst the numbers in the row are the corresponding coefficients of the binomial expansion. The Pascal's triangle is as indicated below. If you are asked to expand and simplify x plus y raised to the power 1, you end up getting the coefficients being 1 and 1. That means you get x plus y. The coefficient of x here is 1, and the coefficient of y here is 1. Likewise, if you are asked to expand and simplify x plus y all raised to the power 2, the coefficients are likely to be 1, 2, and 1. If you are asked to simplify x plus y raised to the power 3, the coefficients will be 1, 3, 3, and 1. And this goes on to the higher powers. And you must note that any number in a row is the sum of the two closest numbers above it. For example, if you take row 5, now let's deal with the coefficient 5. You see that directly above it are the consecutive numbers 1 and 4. So when you add 1 to 4, you end up getting 5. Also, if we consider the coefficient 10, you see that the two numbers directly above it are 4 and 6. And when you add 4 to 6, you end up getting 10. So this is how the triangle, the Pascal's triangle, is generated down to the higher powers. So with this, if you are asked to simplify x plus y all raised to the power 4, the highest power of x will be 4. And the coefficient here from the 4th row, the first coefficient is 1. So it will be 1x raised to the power 4. Then plus the second coefficient is 4. So it will be 4x raised to the power 3 y plus the third coefficient is 6. So it will be 6 times x raised to the power 2 y raised to the power 2 plus, then the fourth coefficient is 4. So it will be 4 times x y raised to the power 3, then plus the last coefficient is 1. So it will be 1y raised to the power 4. So you can see that the first term in the binomial starts with the highest power, then in a reducing form, whilst the second term will also start with the what? The least power in ascending form. Now let's solve some examples. Write down the binomial expansion of 1 minus y all raised to the power 6. And simplify all the terms. Hence, I deduce the expansion of 1 minus x raised to the power 2 all raised to the power 6 in ascending power or in ascending powers of x up to x raised to the power 5. Then I evaluate 0.91 raised to the power 6 correct to 2 decimal places. Now the solution goes this way. We first use the binomial theorem to expand and simplify 1 minus y all raised to the power 6. In effect, comparing 1 minus y all raised to the power 6 to 1 plus x all raised to the power n, x will be negative y and n will be 6. So substituting them as such, we will end up getting 1 plus negative y all raised to the power 6 being equal to 1 plus 6 times negative y plus 6 times 6 minus 1 times negative y raised to the power 2 all over 2 factorial. Then all plus 6 times 6 minus 1 times 6 minus 2 times negative y raised to the power 3 all divided by 3 factorial. Then all plus 6 times 6 minus 1 times 6 minus 2 times 6 minus 4 times negative y raised to the power 4 all divided by 4 factorial. Then plus 6 times 6 minus 1 times 6 minus 2 times 6 minus 4 times 6 minus 5 times negative y raised to the power 5 all over 5 factorial. Then all plus negative y raised to the power 6. Then in simplified form, we will finally get 1 minus 6y plus 15y squared minus 20y cubed plus 15y raised to the power 4 minus 6y raised to the power 5 plus y raised to the power 6. Now let's label this expression A for future sake. Don't forget, the question stated that we should use our result as in A. To simplify 1 minus x squared all raised to the power 6. So what we need to do here is we try to express 1 minus x squared all raised to the power 6 in the form 1 minus y all raised to the power 6. And by so doing, we will end up getting 1 minus into bracket x plus x squared all raised to the power 6. In comparison, y will be equal to x plus x squared as indicated. Now, in place of y in A, we put x plus x squared. And applying Pascal's triangle, we will end up getting 1 minus x squared all raised to the power 6 being equal to 1 minus 6 times x plus x squared bracket close plus 15 times x plus x squared all raised to the power 2 minus 20 times x plus x squared all raised to the power 3 plus 15 times x plus x squared all raised to the power 4 minus 6 times x plus x squared all raised to the power 5 plus and so on. Then applying the exponent law of indices, and simplifying, of course, grouping like terms and adding correspondingly, you will end up getting the final answer being 1 minus 6x plus 9x squared plus 10x cubed minus 30x raised to the power 4 minus 6x raised to the power 5, and so on. And don't forget, we were to end at the 5th power. So we end up neglecting the powers of 6 or higher. Hence the answer 1 minus 6x plus 9x squared plus 10x cubed minus 30x raised to the power 4 minus 6x raised to the power 5, and so on. Then we are to use the same thing to evaluate 0.91 raised to the power 6. By so doing, we need to express 0.91 raised to the power 6 in the form 1 minus y raised to the power 6. And with this, we will end up getting 0.91 raised to the power 6 being equal to 1 minus 0.09 all raised to the power 6. Now comparing 1 minus 0.09 all raised to the power 6 to 1 minus y raised to the power 6, it will mean y is equal to 0.09. And then substituting y in our first expression by 0.09, that's in A, in expression A, we will end up getting 0.91 raised to the power 6 being equal to 1 minus 6 times 0.09 plus 15 times 0.09 raised to the power 2 minus 20 times 0.09 raised to the power 3 plus 15 times 0.09 raised to the power 4 minus 6 times 0.09 raised to the power 5 plus 0.09 raised to the power 6. Of course, evaluating and summing all, we will end up getting 0.567869,252. And approximating to 2 decimal places, we will get 0.57, as the question demands. Now the question 2, example 2 has been solved. So I want you to go and master the solution of example 2. And then go ahead to try the following. That's a trial question. 1. Write down the binomial expansion of 1 plus y all raised to the power 8 and simplify all the terms. Hence, deduce the expansion of 1 plus x minus x raised to the power 2 all raised to the power 8 in ascending powers of x as far as the term in x raised to the power 4. Find by inspection a value of x such that 1 plus x minus x squared is equal to 1.09. Then I evaluate 1.09 raised to the power 8. Correct to 3 decimal places. Now let me give you the clue in the trial question 1. You first expand 1 plus y raised to the power 8 using the binomial theorem. Then you try, you express 1 plus x minus x raised to the power 2 all raised to the power 8 in the form 1 plus y all raised to the power 8. Then you compare and try to find the value of y or what y will be equated to. Now let's come to question 2. That's trial question 2. If the first 3 terms of the expansion of 1 plus px all raised to the power n is in ascending powers of x, that's which is in ascending powers of x, are 1 plus 15x plus 90x squared, find the values of p and n. Now let me give you the clue in the question 2. You use binomial theorem to expand and simplify 1 plus px raised to the power n to the 3rd term. And then you compare or you equate to 1 plus 15x plus 90x squared then use comparison of coefficients to derive 2 equations. Then you solve it simultaneously. So my dear students, we come to the end of binomial expansion. I believe you work hard and master all the solutions, the trial questions, as well as the solved examples. Have a good day. Bye-bye.